Yeah, and this ties a little bit into a study that you were referenced on once, looking at um, the reproductive potential, size, shoot allocation, and growth rates of weedy plants may result from reduced resource allocation to other aspects of plants' growth and defense. And you looked at domesticated sunflower cultivars versus these improved cultivars versus ancient landrace plants, and there were differences there. Can you talk a little bit about that, of how these improved cultivars have differ than more naturalized plants?
Sure. So the Kansas native sunflower looks way different than what you're thinking of when you think of sunflower. So it's not this massive thing that's 9 foot tall with this huge head full of seeds that it can't even hold up. It's like falling over. That's not what the natural sunflower looks like in Kansas. The Helianthus inus is this bushy plant with a ton of flower heads, hundreds of flower heads with teeny tiny seeds and teeny tiny flowers. So we took that plant and we changed it to be this massive single stalk thing with this huge head with fat seeds, for us, because it's much easier to harvest that than going through a million little flowers with some machine. So we selected that. And in the environment we were selecting it tended to be these fields that were tilled every year that had very poor mycorrhizal communities, for example. And these plants, the ones that did well, learned to adapt to those fields with poor mycorrhizal community and a ton of nitrogen and phosphorus applications, right? So as we were selecting for our crops for the traits we want, big fat seeds, we were doing it in this environment that also selected for plants that were less dependent on microbes and really liked a lot of fertilizer. And that's what we have now.
So if we had gone back in time to when they started selecting and we started selecting in the native environment, could we have ended up at a result of the sunflower we know today, but it would have the longevity potential of the native species?
Yeah, I mean, maybe we could always go back and try things differently or try things again. I'm not sure. With the sunflowers that we eat tend to all be the annual variety for the most part. I don't know that there are perennial sunflowers or Helianthus species, but I don't know that any of them have been domesticated. And if anybody is working on that, but that would surely be interesting.
It's part of the food trade-off, right? Is fertilizers relatively cheap.
Yeah.
Annual crops grow quick, they produce food relatively easily, relatively cheaply. So the whole idea of perennializing it, making it have microbial symbiosis and lengthening out the cycle, maybe it's like, why go through all that effort when we can just do it this way? It's fast, it's easy, it works, we know how to do it. You know, we're
Exactly. And that's
the
why it has been done that way since the advent of the steel plow in the 1880s or whatever. It's fast, it's easy, and it works. So why do anything else, right? I guess the downside of that is, in some of these places, we've lost a foot of topsoil, and that took, eons to create. And that's a problem. We're having declining fertility with the loss of topsoil and the constant tillage, for example. And as we learn more things about the chemicals that we spray on our plants, both in terms of harming our own human health and fertilization, harming our biota in our area and beyond, like if you think of algal blooms in the ocean, for example, maybe it isn't the best way. Maybe it helps your corn in your field, but for how long is it going to be a fertile field for your family when you pass it on to them? Or is there going to be 8 more inches of topsoil lost in that generation?
if I had a low tillage or no tillage system with relatively low fertility and a robust microbial community, say I use an inoculant like your mycobloom, and I put it in the soil and I grow tomatoes in that, and I do that for 20 years, and I'm saving seeds and replanting the same species, do you think I'm getting something at the end of that 20 years that's more adapted to that soil and is potentially forming relationships with the microbial communities in that soil, because that's the conditions I've saved seeds in?
Yeah, I think that sums it up pretty well with what's happened with modern breeding, that example. Yeah. I
So
think you
we
would
could
be
go the other
selecting
way.
for microbes and plants that like to live with those microbes in that soil. Mm-hmm. Yeah.
So we can almost like I don't want to say undomesticate, but we could move some of these domesticated species,
Re-domesticate.
yeah, into more like a
Mm-hmm.
regenerative agriculture system.
Mm-hmm. Yeah, I think that's totally possible.
We should.
Unfortunately, it seems like most of the plant and seed breeding that we do does not occur in those environments and with those considerations
So here's a
so
tie-in.
far.
You have your product, Myco Bloom, and we can talk a little bit about that coming up. But if I'm planting crops that are grown, that are have been bred to be in this like fertilization system, organic or not, and I add a microbial inoculant to the soil, are the plants that I put in that going to benefit from that additive?
Yeah. Well, it depends on your plant. If it's a mycorrhizal plant, for instance, that's something to consider. If it's a broccoli or a brassica, it's not going to benefit from any mycorrhizae at all. So it depends on your plant. My strategy with Myco Bloom is I make my Myco Bloom mix as diverse as possible. And so I'm getting ready to release a new product. I don't totally know its name yet, but I'm starting to go with max diversity. And in this product, it has 14 different species, 23 different isolates. So just a ton of fungal. The diversity is really high. And that's in contrast to some of the other inoculant producers, which might have one species or some smaller number of species. And my thought with that, and it's based on nature, is that if you give enough potential via diversity for these fungi to excel in the soil, something is going to work really well. So out of these 23 different isolates, somebody is going to be super great at acquiring the calcium from your soil. Some are going to like it when it's really wet. Some are going to like it when it's really dry. So no matter what the situation, that whole inocula can do well because some individuals in that inocula can perform well in that soil with that plant.